Okay, so what I'm going to be talking about today, so the tagline for this library that I've written, it's called Lambda Query. The tagline, yeah, well, this is just like, I search Google Images for a Lambda, and this is the first thing that came up. The tagline for this library is composable SQL in pure Python. So the idea is that you write SQL in this really composable way, this way that like really heavily supports code reuse, and in a way that's like really intuitive and like really natural. So the motivation for this library is that basically it's like I'm writing SQL. I just got like a job as a data scientist a couple of months ago, and I'm writing SQL. Like I'm writing way too much SQL, and I'm thinking that there really has to be a better way to do this, especially if you're working in data science and you're like making all these massive queries. You're joining like 10 tables together every single time, and it just becomes like a huge pain in the ass. So I was thinking SQL. I know that Simon said a lot of good things about SQL, but I'm here to like say that SQL is not very good. SQL is a really bad language, in my personal opinion. It's really archaic. It's from the 70s, and the only reason that we use it is because like there's basically just nothing better so far. So for the first part of my talk, I'm just going to go through some reasons why I think SQL is really bad. A huge query is like up on the side there, just as an illustration of like why you don't want to write in SQL, because it ends up looking like that and it's completely unreadable. And yeah, it's just really an arduous task. So the problems with SQL that I'm going to outline is that firstly, there's just way too much syntactical noise. Like if you look at a query like this, when you boil it down to the actual like business logic of the thing, there really isn't all that much business logic going on in here. Most of it is just the syntactic noise that I talked about, stuff that the language basically requires. So it's really hard to read. Yeah, like if you look at a query like this, it's basically just impossible to like know what it means just right off the bat. You have to like sit there staring at it for like 10 minutes before you understand what it means, or like maybe someone would have to tell you. And it's super hard to maintain as well. So if you want to like change one bit of logic about a query, you basically have to like delve into the query and like pick out the part of this string. So the entire query is a string, and you have to pick out like the right section where that logic applies, and that's also a really arduous task. And the third thing is that the scope for the code reuse is minimal. So basically in SQL, it's like there's a few ways to encapsulate code, to reuse code in SQL. One of them is like creating views, and then the other thing is like making these subqueries. So putting another query as a subquery of another query, and then just selecting from that. And that's basically the only two ways that you can reuse code in SQL. There's probably more, but like, those are the two obvious ones. CTE, yeah, so that's the term that I don't use very much. And writing really complicated queries is just super difficult, like I'm really stressed. So just quickly, I work at a place called freelancer.com. I thought it would be nice to just go through the database structure before we continue, because I'm going to be using the table structure at Freelancer for a lot of these examples. So what happens at freelancer.com is that people create these projects, and freelancers come and bid on the projects. So the projects are like web development or they're like graphic design, mostly those two categories. And then the employer awards the freelancer of choice to complete the project, and then payments are made in the form of these milestone payments, which is basically like you put down a payment, and then when you're happy with the amount of work that the freelancer's done, then it gets released. So like until that time, freelancer basically just provides this escrow service. And so from that, there's three tables. There's the projects table, there's the awards table, and there's the milestones table. So I'm just going to be using those three tables as my examples throughout this talk. So if we go right into why SQL isn't a very good language, the first thing is joining. You have to join things a lot of the time, especially if you have your database like highly normalized. If it's like in 6th normal form or whatever it is, then every single time you need like a new property, you have to join it to another table, and that just gets really, really tedious. So an example here is for a project, suppose you want the budget of the project. Well, you can't just access the budget directly because like on the project table, there's only like a number that's like, there may be in a different currency. And if you want to just convert that all to the same currency, like you want to convert it to US dollars, then you've got to join it to the currency table. And if you want another property, which is like the country of origin of the project, you have to join it to the user table because the country is only available on the user table. So like straight off the bat, it's like, you want these two properties, they're really commonly used, and immediately you have to join out these two tables. So, and that's just part of the syntactic noise that I'm talking about, because it's really obvious how you want to join it. There's only one foreign key. It's like you should just be able to say join, and then it just figures out all of this by itself. So you shouldn't have to type out join every time. So suppose you could write it like this instead, where instead of like joining it on the currency, so the project table is P here, so I use the alias P, but instead of having to join it on currency on the currency ID, suppose you could just say like p.currency.exchange rate instead of cur.exchange rate, which is up here, which is like after you've joined the currency table. And suppose that instead of using u.country, you could just write p.user.country. Like immediately, you don't have to do any joins, and it just figures out what you want to do. So this is the kind of thing that I want to really promote to this library, is like really getting rid of the syntactic noise and just boiling down a query to the actual budget. So yeah, you might think that that's no big deal, right? It's like for just these two properties, so what? You just have to join an extra two tables. It doesn't take up all that much more time, and it's still like fairly obvious what you're doing when you just read this query. But then when you start scaling it up, then you get some issues. For example, if you want the budget and the project ID, and whether the project is from an English-speaking country, but only for projects where the seller is also from an English-speaking country, then you have to, because if you want to find out the seller of a project, the freelancer of a project, you basically have to join it on the award table, and then join the award table to the user table again. And then you have like two user tables, and then you've got to name them to remember like which one refers to which. You've got to say like, oh, okay, I'll give this one the name of seller, this one the name of buyer, so that I can personally remember, which one of these tables refer to which one. And I want to filter by the seller part, and up here I want the buyer part. So it's like there's all this mental overhead. You have to keep track of like what refers to what, and that's also part of the thing that I want to get rid of. So yeah, you have to keep track of what name refers to what table. And again, there isn't all that much logic here because I can just say it like really quickly in English right here. And from this, it's already really obvious what it means. But when you write it out, you have to write out like all of this kind of baggage on top. And of course, it's really easy to make a mistake because there's two user tables in there. So yeah, the other problems is that, so if you write it like this, if you were doing that same paradigm that I mentioned before, where you could just write like p.seller.country, and then not only does it shorten the query by a lot, so it's like you completely get rid of all of these joins, but you're completely removing like the ambiguity as well, because before you had two user tables, but now you have like p.award.seller, and that's really obvious that that's the seller. And then up here you've got p.user, which is like the buyer. So you don't have to go out of your way to like name all these columns, name all of your tables. There's less of that mental overhead. There's less ambiguity, and this is also really highly scalable. So joining is just one example of the syntactic noise in SQL. The other examples, so just like syntax quirks. For example, like whenever you take an average, normally you want to do the coalesce 0 every time you do an average, pretty much, and that gets really annoying. Using null if to avoid division by 0, and then like coalescing the whole result again. Like there's literally things that you have to do every time you divide. Like every time you divide, you cast the numerator as a float, and then you divide, or like there's missing like those are problems with every single language, but they're particularly annoying with SQL. Missing the end statement, for example, especially like the case when end, and then I spent like 5 or 10 minutes looking for where the syntax error is, and it's just because you miss an answer. So here I have an example of a query where it's like for each project, I want the average number and amount of milestone payments received of its bidders in the last 7 days. So like each project has a lot of bidders, and then the bidders can receive payments, but you want the average amount of payments of all the bidders on the project. And then when as soon as you like need like multiple layers of aggregates like this, then SQL just starts getting out of control. And you see you have a subquery here, and then you've got to give that subquery a name. It's called bid amounts, and then you refer to the bid amounts like down here. You've got to join on bid amounts, and then here you've got to like name every single column that you selected in the subquery. So like you call that number of transactions, you call this total amount, just so you can refer to it out here. That's super tedious as well. It's like you've got to keep track of which columns refer to which columns, and these columns are basically just dummy names. Like it doesn't even matter at the end. You're basically giving these names so that you can remember what they are. Like it's all for the benefit of the human, right? Whereas the computer, in the back end, it's like it doesn't really care. It does care about like what you name the columns at the end, because that's what the columns are going to be called when the query gets run. But these intermediate names just don't matter at all. So that's another part of the syntactic noise of SQL. So the redundancy is throwaway names for columns and tables. I already mentioned that. There's including these columns in these inner queries just so that we can refer to them from the outer queries. Like sometimes you want to refer to something in here from out here, but because of the scoping rules, you can't just directly refer to it out here. You've got to like include that as a column in here, and then use this to refer to the column that you've included in there. So that's really annoying as well. And then there's grouping by things. So grouping by everything that's aggregated, that's like really obvious. So if you have like 5 non-aggregated columns and all the rest are aggregate columns, you obviously want to group by all the 5 different things. Like otherwise, there's just no way to do it. But then it still stops you saying that you have to explicitly group by that. So that's really annoying as well. And the final thing is it just takes several tries to get right. Like if you want to write a really big query in SQL, it usually takes me like before I use this library, before I create this library, it would take like 10-15 minutes, and you'd just be sitting there like running it, and then there'd be like this little error, and then you go fix the little error. It took like 10 tries to get right. So that was like on average. And then there's the I'll just skip this section. So the legibility of the SQL. So why, the question is, it's really hard, and there's heaps of syntactic noise in SQL, and the question is, why is it so easy? Like, why is it so easy to say what you want? In plain English, you can just say what you want. For example, a time series of the average budget of projects that had at least one bid from a user with at least 5 milestones. Something like that. You can just say it, and it's just one sentence. It's relatively unambiguous what you mean, but then somehow it just has to become like so hard in SQL. I mean, the business logic of it, again, like I know I'm repeating myself over and over, but the business logic of it is really not all that big, but somehow when you convert it into SQL, it just becomes like really big. So yeah, I think this was the same query from the last slide. Yeah, so again, this is the average budget of projects that have at least one bid for with at least 5 milestones. And there's all these subtleties here as well. Like here, you have to group by an ID here, which isn't included in the columns. And like that's a fairly subtle point, the kind of point that you can kind of only arrive at after you see the result and you notice that it doesn't quite look right. And then you're like, okay, what's going on here? Is this subquery returning exactly what I want? Is it returning like one row for every single bid, which is what I wanted, or is it returning one row for like every single project, which is not what I wanted? So again, it's like you translate from English into SQL, and then not only is there all that syntactic noise, but then there's all these like subtle points that you have to figure out for yourself. And then there's the code reuse in SQL. So, like I said, there's not that much scope for code reuse in SQL. Basically, the two things that you can do is you can make functions that output strings. So you can do things like, you have this library that basically all it does is stitch all these strings together, and then maybe you have a function in Python that like inputs all of these strings, and then it takes in all those strings and spits out a query, or like it spits out a segment of a query, which gets stitched onto the output from another function, which is like the first section of the query. So these use cases are really narrow and they're really hard to maintain. Like anyone who's tried doing this kind of thing where all you do is stitch a bunch of strings together, like that quickly it just becomes like completely unmaintainable, or like you have these situations where you want to fit this square peg into a round hole because the structure of your function dictates that the query has to be written in a particular way. And when you want to change like one small part of it, like one small part of the logic of it, then you have to write like an entirely new function. And then, of course, I already mentioned this. The other way you can reuse code in SQL is you can write like views, you can write subqueries, you can have like list statements, which is the CKEs. And this is basically the only language-supported form of code reuse. So what we want, sorry?
Temp tables.
Temp tables. Oh yeah, temp tables, which are kind of like views. Yeah. So, so when you can't reuse code in SQL, it kind of just becomes this complete nightmare. Especially when you have to do like the same thing over and over again. So like converting a string to an integer, and then like doing that for 5 different columns, and then adding all the columns up. It just becomes like, you copy and paste one section, and you paste it like 5 times over, and then you change like one thing. The experience of the novice programmer, basically. So copy paste is your only friend. What we really want, and what I'm trying to get out of this library, is this true code reusability, and just basically something that enables you to use what you already have in this really natural, really intuitive way. So the solutions. I'll just go through the things that already exist, because what I did at the beginning was I looked at all the different libraries. I thought there has to be a better way than this SQL. So I looked at all the existing libraries to see if there was something better. And there's all these ORMs. For example, there's like SQL Alchemy. And one great thing about SQL Alchemy is that it gets rid of that syntactic noise of the joining, because like you define the foreign keys when you define the tables, and then like it knows what you want to join on. And you just say like, dot join, whatever other table. So you don't need to specify the foreign key, and then you can define like all of these custom properties, like you can define the length of something. For example, if there's a table of pieces of string or something like that, and there's like a start point and an end point, then you can define a function that's like the length of the string, and then treat that as if it were just another column of the table. So you can do that, and then you can say like, okay, this like a piece of string contains a point if the point lies between the start and the end. It intersects another string if the one string contains the other and the other string contains it, or the other string contains it. You do get like a lot of extra flexibility with SQL Alchemy. But the problems with SQL Alchemy is that it basically just becomes like its own language. Like when you want to do something really complicated in SQL Alchemy, when you want to write like a really big query with like these kind of obscure options, like of the kind that I wrote before, of the kind that I had an example of before, then it just becomes like super hard as well. Like it's basically harder to write a query like that in SQL Alchemy than just writing out raw SQL. And it's because, I'll talk about this later, but it's because I think the kind of conceptual structure of the thing is wrong. But just staying on SQL Alchemy for now it's confusing when you have multiple copies of the same table. It does have these hybrid properties where you can use like columns from other tables to define properties like from your base table. So in that first example that I used, where you have like the budget of a project, you can basically define the budget of a project, even though that uses data from another table, and then use that budget of the project just as if it were another column in the table. So yeah, it definitely has really good sides, but then there's the downsides where if you get really big and you start having to know all these obscure options about SQL, and it just becomes even harder to write SQL. So a note on ORMs, like this is pretty old, like it's from 2004, I know like things have been really different since then, but there was this famous blogger who said like, ORMs are like the Vietnam of computer science, and basically what he meant by that was, you can have lots of raw power with SQL. Basically, like for all the shortcomings of SQL, the amount of raw power that it gives you is just completely unparalleled. Like you can have really fine-tuned control of what goes into your query, and that's just not available in an ORM. Or it is available, but the thing is like, if you want this particular functionality in an ORM, it just becomes like this ad hoc feature of the ORM that gets added in like the next version. And yeah, that just never ends because like there's always going to be these corner cases that it doesn't have. So what I think is like this might be an unpopular opinion, but the reason why this attitude is not entirely false is because I think the abstraction is kind of just wrong. Like you're treating tables as like the standard abstraction is like a table is a class, and then columns are properties of the class, and rows are like particular instances of the class. But what you really want is an abstraction where the table is like a list. So if you could imagine that all the tables in the database were just lists of objects in memory, and if you could like write as if this were the case, what would the syntax look like? It would look basically something like this. Like you start off with an empty list, you say the result equals empty list, and then you just loop over the table that's in memory. You say for P in projects, append the project ID, the country of the user, and the budget of the project. So what's great about this is that it lets you think in terms of one term at a time, and it doesn't actually look like we've saved all that much space here. But the thing about this is that it actually completely supports code reuse. Like you can define a function on a list, and then you can just reuse that function like over and over, like wherever you want. For example, you can define like, kind of like an SQL query, you can define the budget of a project as just this, and then just keep using it for everything. And yeah, and it also has the benefit that's like, well, if the table were just the list in memory, then we shouldn't be restricted by all these like scoping rules and like all these rules for what you're allowed to group by, like rules for all these other rules. Because basically, if it works with lists, then it should be able to work with this framework as well. So there are frameworks that already do this. So list syntax. With the list syntax, anything you can do with lists, you can also end up doing. So for example, here, you have something that's like this takes a while to understand today. But this is for each project, you want the average number of milestones by people who bid on that project, right? So when you write it down in SQL, it looks like this. And then when you aggregate, because aggregation is kind of like a special case, you need a subquery here. So with list syntax, you basically don't need the scoping rules anymore. Like if it works with lists, then it should work. It's 4 PM projects, and then for B in the bids of the project, you append the length of the milestones of the user of the bid, and then that just becomes like your row. So you have for each P, you have like this list of lengths of milestones, and then you take the average of that length, and that's your result. So even more concise, you can write it like this with generators, and it just becomes like super obvious what you mean. You've completely like abstracted away all the syntactic noise, and all that's left is like the business logic. And there are libraries that already do this, but the libraries that already do this, like I didn't have much experience with these languages. I looked looked into, there's Opali in Haskell and there's Quill in Scala. Like I didn't have that much experience with those, but like I did look quite a bit at Opali, and that was like really lacking in the features that I wanted, which is what led me to write this thing again. So there is one thing that almost does this, so that's like really close, and it's called Pony ORM. So Pony ORM, it's basically, it's marketed as like the ORM with beautiful syntax. And it's because you can treat these tables as if they were in memory lists. But the problem with this, so here you're just writing a query as like a list comprehension. And then the list comprehension gets compiled into SQL and it ends up looking like that. It seems to do almost exactly what you want, but the thing is like, this is, I don't know exactly how it works, but I think inside this select statement, you're only allowed to use these particular functions that like PonyORM knows about. So if you define your own functions and try to use it inside here, like you just get an error. It's just, yeah, you can't use it inside this select function because PonyORM doesn't know what to do with it. And yeah, it ends up just all being like the charade of doing what you want because there's no composability at all. There's only like this list syntax. It does a really good imitation of what a completely Pythonic query API would look like. So because there was nothing that was entirely satisfactory to me, I ended up writing this thing called Lambda query. And what I wanted was that you get rid of all the syntactic noise. So, for example, you get rid of joining by foreign key. You get rid of all that, like the red tape, like coalescing and like casting and float and all that. You get rid of the dummy variables and tables. So every time you write a subquery, you have to name all the columns, name all the tables. I wanted to get rid of that. And knowing which tables should be left joined. So a lot of the time is like when you left join one table, and then you have like a condition on that table, you have like a second table that's attached to the first left join table. Then like every time you refer to a column from that first left join table, you've got to add this extra condition that like the second table is not null as well. So that's another piece of syntactic noise that I didn't mention.
That's an assumption for one particular set data. That's not necessary. Sometimes you want to know.
Yeah, definitely sometimes you want to know. But for example, if I want like payments on projects that only satisfy a particular condition and like those payments may not exist, then you have to left join on the payments and then left join on the projects. And then say like, if you want to sum all those payments, you've got to say like some case when the project table is not null, of the milestone tables are null. Yeah. So it's like another case where it's really obvious what you want, but you've got to think for ages about how to write it. Still. Knowing which relationships are one-to-one, and choosing the group bys appropriately to preserve the structure of the row. So if you want like one row for every single entity of X, like one row for every single project or one row for every single user, then it should be able to figure that out by itself. And then there's full code reusability. So we actually want it to be like working with Python lists, and we can work with either particular elements of a list. So you can have functions that like take elements to elements or even elements to other lists. Or you can work with the entire list as a whole. So for example, an aggregation function can be seen as something that takes an entire list and gives you one number because it's aggregating that whole list. Or it takes you like a list of lists and then gives you just a list, for example. And then the syntactic clarity, like it's super clean syntax, just like bona fide Python. And the last one was to minimize the boilerplate. So in Lambda query, this is just like an SQL alchemy where if you want to join by foreign keys, it's just really easy. So like, this is all the project IDs from the project table. This is like all the users of the projects, but the user IDs of those. So because when you define these classes, you already define foreign keys. When you write something like this, it already knows like what to join them. And then you can just make like a really long chain of them like that. Because every user has a bunch of bids, every bid has a bunch of milestones. Milestones might have reviews, and then it just comes out really nicely like that. So this is the beginning of it. When you want to define functions, so for example, you want to define like whether a project is from an English-speaking country, you say, you define this is a property, like this is in the class definition where you write this. This is a property of a project where a project is from an English-speaking country. If the user of that project is in an English-speaking country. So the way you apply that is you have like the project query, which you can think of as like this entire list of projects, and then you F-map this property, which is like applying it to every single element of the list. So you have the project, for every project, you get whether the project is from an English-speaking country, and it just comes out like this, and it's exactly as you expect. So this 5i property, which is whether the project was from an English-speaking country, that's now accessible to anything that has a user ID. You just have to write like any like column, entity that has a user ID. You just have to write the thing and then .user.5i, and it'll just roll over. So with the list syntax side of it, it works pretty much exactly as you want it to work. If you expect a unique row for each such and such, you'll usually get one. So instead of like the syntax is slightly different. So instead of writing for p in project.query, you write p equals yield project.query. So you can modify like a lot of the inbuilt methods in Python, like the dunder methods, but like I couldn't figure out how to make it work for this, so I went with this other syntax, which is, some might argue even better because you don't have to indent every time you have a meeting. So here, what I have, so that example from before where we looked at the average number of payments for the average number of milestones for the bidders on a particular project. So for that example, remember when we wrote it completely Pythonically, it looks like this. So for PM projects, the number of milestones equals this list of the length of the milestones of the user for the bids of the project, and then you return this. And in Lambda query, it's pretty much exactly this. So in Lambda query, you just write p equals yield project.query, and then instead of return, there's a return n, and then what you return is the average of the users of the bids and the milestones of the count of the milestones of the users of the bids. So it's like you just chain it together like that. And it comes out exactly like this. So this is how it comes out. Here it goes to group the unit table by the bid idea because that's how the chain started. And like all the group bars get figured out for you. Like this coalesce 0 gets figured out for you. All of these like intermediate table names also get figured out for you, so you don't have to like write that and remember what it's called, so you can join on again. It's basically exactly what I talked about. And to really like show off the power of it, so we can try something a bit more complicated. So firstly, like in Freelancer, you can get these things called memberships, and in the memberships like basically let you get more bids, right? So in the membership table, it has like a user and then a start timestamp for that membership and an end time for that membership. So you can write a property that's like so here, you can write a property that tells you how many bids there are for a particular type of membership. So like, professional membership gets 300 bids, basic gets 30 bids. And then you write it like that, and then you can just use that as a property here. So that's the first step of it. So what about if we're given a particular user at a particular time, and for a particular user at a particular time, we don't know what membership that user is on at that time. So here you say the memberships of the user then this is why it's called Lambda query, because you use a lot of lambdas in it. You filter by this condition that's like the timestamp. The timestamp of the membership is, the timestamp of this thing, of the thing that you're trying to take a copy of self, is between the start and the end timestamp of the membership. And because sometimes it doesn't have an end timestamp, you gotta have like, this coalesce with a time now. And yeah, so that's for a given time and a particular user. We want to know the membership that user will have at that time. So you basically just write it like this, and then you have for each award, what was the membership of the user on at the time, and then because this is just like a membership object, then you can start chaining all the attributes of membership objects. So like package is an attribute of the membership object, and then of course it just comes out like that. But then, so I want to emphasize composability here. So we have this function that for a particular time and a particular user gives us the membership that the user was on at that time. And then we have another function that for a particular membership, it tells you how many bids that membership has. And you can use those together, and you can say, for each bid, we want to know if it's a bid that exceeded the user's theoretical limit number of bids that they had from the membership at the time. So you say, you define another property, the bid is over the limit, where like the bids of the user in the last 31 days, the total count of those is greater than the membership plan of the bid and the max bids of that membership time. So this is like the total number of bids made by the user in the 31 days prior to the bid, and you just want to check if that's greater than the maximum number of bids allowed by the membership plan that the user was on at that time. So note, like when you read this, it's just super intuitive. Like you can read this, you can like instantly know what it means. It's like, okay, this is the number of bids in the last 31 days, this is the total number of them, and then this is the like maximum number of bids that the user is allowed. So you can read it and instantly understand it. It's completely defined in terms of what we previously defined. And then you just use it in a query like this. So bid 0 for each, you're basically saying here again, for each bid in the bid table, you return the user ID of the bid, you return the rounded timestamp, and you return the proportion of those bids that were over the limit. And then, it just comes out super nice. So it just comes out like something really big, as something that, that you can reuse over and over. And this is basically something that would have taken me like 10 to 15 minutes to write without this. So there's 2 layers of aggregation here, but all of the dummy names get handled for you. Like all of the red tape gets handled. Like matching all the brackets would be like really hard here. And the query was actually basically exactly what I would write if I would write the SQL by hand. So there's a functional part of Lambda query, which is you can basically write queries in this complete point-free style. So here, what point-free style means is that here you're saying like for every bid in the bid table, do this and this to the bid. But you don't have to refer to that bid directly. You can like refer only to the bid query, to the entire table, like in its entirety, and then you can use all those like operations that you have on lists, like concatenating lists, or like flattening a list, or mapping a function over lists, and you can use entirely those things. So like I have this at as a like functional composition, and then you say, okay, for each bid you get the awards, and then you get the membership of the award, and then you get the membership of the package, and you don't have to refer to like any particular bid.
Would it generate the same query?
Like if it was like this wasn't the query that we had in the previous example, but if you wrote, so there's like basically like I'm probably running out of time now, but there's like this entire algebra of like operators on the query, and then you can like add them together, you can multiply them together, you can add them together. So it's like this complete like building block. You can build these queries out of these really small building blocks, and they're all like completely useful. So that's the best way of that. And yeah, I'll just skip that part. So the summary of the Lambda query is that it handles all the red tape. It makes query writing a lot faster and a lot more intuitive. And you build your query with composable pieces instead of with strings. There's huge potential for code reuse, and it never generates invalid SQL. And like some extra features that I added was like, you know, cleaning the data, so like imputing the missing values, these kind of things. Like I had that as an ad hoc extension so that I didn't have to do that after I ran the query. But yeah, I basically have the entire pipeline in one environment, the entire machine learning pipeline, so down to, you know, optimizing the parameters of your models and normalizing the data at the start before that's it. Yeah, so that's it. I'm working on it like a load at the moment, so contributors are really highly welcome. Yeah, I would really like to have contributors on this thing, and because it's basically the first big project that I've ever written in Python, and yeah, there's probably a lot of things that I'm doing.
Questions? Cool. Yeah.
You got an elf, by the way.
Of what, sir?
Elf.
No, I haven't heard of that.
Yeah, you should look it up.
What about writing?
What about what, sir?
So you're reading.
Yeah,
How do we write? So
there's no writing it.
Are you going to be using an ORM, or like do you expect some other process, some other microservice to be writing directly into the relational database?
Yeah, like I don't have any support for writing at the moment. Like, you know, I'm a data scientist, so like I'm not inserting any data and I'm like getting it down.
So you just
So
expect
they'll be writing when, you know, when there's a use for it.
Question? Anyone else? Cool. I think this is actually a very cool idea, and this is something that a lot of people eventually, if you go on the way, you might actually discover that you reinvent SQL. I'm not joking. I actually went down this path before.
Yeah.
So COD actually, what you did basically is really recreating relational algebra, right? There are some subtleties. There are some edge cases, I think.
Yeah.
That is only relevant to you, so like the left right thing that is imposition on library.
Yeah.
So you know, if you are to cater for every single possible edge case, you can reinvent SQL.
Yeah.
But as far as limited subsets of SQL go, fantastic idea. I used it. Oh yeah.
Yeah.
I actually used it.
Oh, right. I don't think anyone, because there's like no documentation on it.
We all read code,
Oh, yeah.
right? So, as a guy who has actually used, he talked about Lambda, and for a bit more context, I used to run a startup that dealt with simplifying SQL for people. So clearly this was in my field of interests. So I actually used his library when he introduced it to me last month. I went to play around with it. I found it to be very useful. So you guys should probably use it. Anyone else has any questions?
Yeah, for sure.
Can you
Yeah.
pick it up? Yeah. There you go. That's the address. I would recommend you at least try it. It doesn't quite work on like Redshift or anything, but if you've got like a toy SQL
Yeah, it's only for Redshift at the moment. Yeah, it's like, yeah, it's Redshift.
Yeah. So, you know, play with it.
Okay. Thanks for listening.